Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Ketoenol tautomerism stability is governed by resonance stabilization, aromaticity, and the relative energies of keto versus enol forms. Moving on to the next step. Analyze structure 2-bicyclo 2.2.1 heptane 2-1 norcamphor. This is a simple ketone, keto form. Ketones are generally more stable than their enol tautomers due to the stronger C is equal to O bond compared to C is equal to C plus OH. This is the standard keto form and is typically the most stable tautomer in simple systems. Moving on to the next step. Analyze structure 3-bicyclo 2.2.1 hepta 2,5 DN2-ol. This structure has two double bonds in the bicyclic framework with an OH group on one of the double bond carbons. This resembles a phenol-like enol where the OH is conjugated with the diene system. The conjugation and partial aromatic resonance stabilization makes this enol more stable than a simple enol. The extended conjugation, cross-conjugated dienenol, provides additional stabilization compared to structure I. And for the final step, analyze structure I-bicyclo 2.2.1 hept2N2-ol. This is a simple vinyl alcohol, enol, with one double bond and an O. Simple enols are the least stable tautomers because they lack extended conjugation or aromaticity, and the simple C is equal to CO system is higher in energy than the corresponding ketone. Establish stability order. Structure 2 ketone, structure 3 conjugated diene enol, structure I simple enol. The ketone 2 is most stable due to the inherent stability of the C is equal to O bond. Structure 3 is more stable than I because of the extra double bond providing conjugation with the O, giving partial resonance aromatic character to the enol. Structure I is the least stable as a simple unconjugated enol. Why other options fail? A. I to 3 incorrect simple enol I cannot be more stable than ketone 2. B. 3 to I incorrect the conjugated enol 3 cannot surpass the ketone 2 instability in this non-aromatic bicyclic system. C. 2I3 incorrect I being more stable than 3 ignores the conjugation advantage of 3. Therefore, the correct answer is D. Therefore, the correct answer is option D.